So in this video, I will show you how you can go from this to this all under 9 minutes, start to finish using one software, Global Mapper. No paid data, just a clean workflow that actually work in the real world so you can get immediate conceptual design and be the one leading the engineering, not your drafter. So let's dive in. I downloaded this data from the US Geological Survey. It's about 1 meter resolution, roughly 3 feet. This whole area is under active development with easy access to major highways. And if you look closely, you can already see a few existing stormwater ponds nearby. That tells me something right away. This site is likely getting a lot of runoff during heavy rain, which means our job here isn't just about managing water, but also capturing sediment before it moves downstream. So first things first, I'm going to change the pond's solid color, just to make it easier to see what's going on in the layout. Now, when it comes to building this pond, I'm going to start with the berm first. I know that's counterintuitive how it's actually built in the field. In real life, you dig the pond first, then shape the berm to the right elevation. But in this workflow, starting with the berm helps us remove the terrain easier. So the first step will be building the berm footprint and assign elevation. Then step 2 would be creating the berm terrain. And finally, step 3 would be adjusting the bottom. Pause the video to see the cross section if you are not clear. Now that the setup's ready, the next thing I want to do is determine the top of the berm elevation. To do that, I'll cut a few profiles, one along the length of the pond and another across its width. This helps me see how the ground behaves in both directions and where the berm needs to sit for a balanced slope. Once those are done, I'll also cut a profile around the perimeter of the pond. That gives me a clear picture of the bottom elevation and confirms how much material needs to be excavated. It's a quick way to visualize the whole system before I lock in any grading changes. Here, I'm measuring the slope of the drainage and looks like it's about 5% slope, which is not too steep. I need to know this number because it will help me understand the erosion requirements when water released from the pond. Okay, next I'm going to pick the perimeter of the pond and use the path profile feature. What I'm looking for here is the elevation for the top of the berm. This is one of the most important steps. If you get this wrong, and the berm could end up too high or too low, and if it's too low, the next big rain might just turn this place into a muddy community pool. From the profile, it looks like about 488 feet is a good elevation for the top of the berm. The bottom sits around 474 and some change, which means this pond will end up roughly 15 feet deep, a reasonable depth for a pond of this size. It keeps the cut volume manageable and the structure balanced. That setup also helps the berm blend naturally with the surrounding terrain instead of sticking out like a wall. Now let's put that 488-foot elevation into action. I'll show you exactly where that value fits into the process. First, I'll enter it as the target elevation for the berm. That's the top surface we'll grade to. Then, as we move through the next steps, you'll see how Global Mapper uses that number to shape the berm and balance the surrounding cut and fill. All right, now I'm going to show you how to create the top flat portion of the berm from a line. To do that, I'll use the buffer tool and create a 5-foot buffer on each side of the line. That gives us a 10-foot wide berm top, which is about the width of a single lane. Enough space to safely drive a small utility vehicle, a riding lawnmower, or even a golf cart. But just to be clear, it's not wide enough for large trucks or construction equipment. This is meant to represent a stable maintenance path, not a full access roadway. I'm going to call this layer berm areas. Also make sure create rectangular buffer rather than rounded buffer is unchecked if you want round edges on your berm. Now that we've got the berm top defined, the next step is to elevate this area to our target elevation. To do that, I'll select the area, right-click, and go to Edit Vertices. This opens up the elevation values for each point along the berm. As you can see, there is no elevation value, so I add that from terrain. We have to make sure all of the elevation values are fixed to 488 feet. Once that's done, I'll select all the rows using the Shift key, enter the elevation, and apply it. Now here's a quick trick. Global Mapper doesn't take values in feet for this table, so we need to convert this feet value to meters. So let me pull up my trusty Windows calculator to do that. If you're like me, used to the metric system but working in the US, you probably know these conversions by heart. But for those used to imperial units, let's just say most of them think a meter is something you park next to. Just kidding. So I'm going to enter the converted elevation of 148.73 meters and hit OK. This will make all the vertices on the same elevation, much like the top of berm we will create. But before we create the berm, I'm going to confirm if we have done this correctly on 3D view. It should give me an elevated look. Yep, as you can see, the top of the surface is on the same elevation, and this is more visible at the lower elevation. It's already looking great for our future pond/landing zone for curious docks. Now we can move on to creating the berm. To build the berm, I'll select the area and go to Advanced Feature Creation Options, then choose Create Flattened Terrain. Here's where an important distinction comes in. We'll set the fixed height to 488 feet, which defines the top of our berm. For the cut and fill slopes, I'm choosing 18.5 degrees, which is roughly a 3:1 ratio. There are a few other parameters here, but that's a topic for another lesson. For now, make sure to check the box for Add Measurements to Area. This keeps your cut and fill volumes saved as attributes instead of showing them once and disappearing. Let's head over to 3D view and check our berm. It turned out pretty good. You can really start to see the structure taking shape here. The slopes are smooth, the top is flat, and it ties nicely into the surrounding terrain. This is one of the reasons I like using Global Mapper for conceptual grading. You get immediate visual feedback. You can spot issues and adjust elevations, and if something doesn't look right, you can go back, tweak the parameters, and rerun it in seconds. No waiting for new files or data. Next, we're going to select the area inside the berm and modify the inner terrain to reach our target elevation. If you remember, we decided that a 15-foot deep pond would be sufficient. That means we'll lower the inner terrain to a fixed elevation. That's exactly what I'm going to do here, but there's one small difference you'll want to pay attention to. Instead of modifying terrain outside the berm like we did before, this time we'll focus inside the area. We'll lower the inner terrain down to the target elevation of 473 with exact same cut and fill angles to form the pond bottom. Let's look at it on 3D view. Yup, the berm looks great. You can really see the shape of the pond now. The berm stands out nicely, and the edges ties to the existing ground, just as we planned. Let's take a look at the bottom and confirm the elevation. Yes, it looks like the bottom was lowered correctly. Hope you enjoyed this video, and if you want to learn more about site design in Global Mapper, check out this next video. I'll show you a few tricks that'll cut your design time in half and make your life a lot easier.